So we say there are three types of simple machines: pulleys, levers, and inclined planes. Here are three different pulley systems. So let's start with the very first one. If I remove this hook, right, or the string off the hook, hopefully you can see that I'm overcoming the weight of some lead sphere, but it doesn't take much effort on my part with my right hand. Now if I measure how high this object goes, maybe, okay, that far. But my hand over here moved much more than the distance that this object lifted up. In fact, you can probably see that my right hand moves 3 times as far as the object lifts. If you can't see that, it's easy to understand why that would be the case, because as this one string gets longer, there are 1, 2, 3 strings that get shorter. And so by definition, this pulley system has an ideal mechanical advantage of 3 to 1. Is the actual mechanical advantage 3? I don't think so. Listen. Can you hear it? Maybe not. It's a little bit squeaky. So let's say this thing weighs 30 newtons. In the ideal case, I should only have to apply a force of 10 newtons. But what if I apply a force of 15 newtons to overcome a weight of 30 newtons? Then my actual mechanical advantage would only be 2 to 1, even though the ideal mechanical advantage is 3 to 1, and I would have something like a 67% efficient machine. I bet you this one is better than 67% efficient. So if this was 30 newtons, maybe I don't pull with 10 newtons, maybe I pull with something like 11 newtons. What's 30 divided by 11? A little bit less than 3. In any case, the actual mechanical advantage will always be slightly less than the ideal mechanical advantage, just based on not only the internal friction of the system, but notice if I were to try to lift this sphere by itself, all I have to do is lift the weight of that object, but by using the pulley system, I also have to lift the additional weight of the pulley. So there's a bit of a cost, but regardless, the cost is in the work that's done. I have to do a little more work input than I get output, but I still get to do it with a smaller force, right? In the ideal case, if this is 30 newtons and the ideal mechanical advantage is 3, then I pull with only 10 newtons. I might actually have to pull with 11 newtons, but still 11 newtons is less than 30 newtons. So a simple machine will always allow you to do some amount of work by using a smaller effort force than the actual resistance that you're trying to overcome. With this pulley system, it's an even better mechanical advantage. Now there are 1, 2, 3, 4, 5 strings that are getting longer. So if this weighs 30 newtons, then I should only have to apply 6 newtons of force here. However, there's even more moving parts, so there's a greater amount of internal friction in the system. And because I'm using a double pulley, the additional weight is even greater. So as I add more and more lifting strands, the efficiency is likely going to go down. By the time I get up to, what does this one have? I believe it's, we can count them, 1, 2, 3, 4. This one has 7 lifting strands. And so the amount of force that I have to apply is very small, but you can really notice that there's a trade-off taking place with distance. If I want to lift this just a few centimeters, notice how far I have to pull with my right hand, right? My effort distance greatly exceeds the output distance. And in doing so, I'm lifting this with a very small power input. It's going to take me a lot of time to do the work.